So for 6.6, we are dealing with something new called inverse functions. We have worked with inverses before. We've had two types of inverse so far. The additive inverse, which is the same as the opposite. So additive inverse of, say, positive 4, what would the opposite of positive 4 be? Negative 4. Okay? We also have the multiplicative inverse, which we also call the reciprocal. So if I gave you 2/3, what would the multiplicative inverse of that be? 3 over 2. The sign stays the same though, right? So those are the two types of inverse we've worked with so far. They're up here in the blue box. Today we're going to be working with finding the inverses of functions. So let's define that. Two functions are inverses of each other if, when I compose f of g of x, I get x as an answer. And then if I flip it, g of f of x, I also get x as an answer. So that's how we know if two things are an inverse. That's the official definition. We have a type of notation that we use. So now instead of having to say g and f are inverses of each other, we call the inverse of f, f to an exponent of -1. But we read it as f inverse. So when that exponent -1 is attached to the function, it's not an exponent. It indicates that that the function is an inverse. Okay, so we don't have to move it down to the denominator. We don't have to flip it at all. This is just the type of notation for explaining that that function is an inverse. Okay, so we read it as f inverse. This is not acting as an exponent in this case. It's just a notation. A way to write this a little bit more clearly, if your original function is f of x, then you would write the inverse function as f inverse of x. If your original function is given to you as y, we write the inverse function as y inverse. And that is a -1 up there that I just kind of wrote over. Okay, so if our function is f of x, we write the inverse f inverse of x. If our original function is given in terms of y, which can also happen, we write our inverse as y inverse.
Is that a -1?
It is. So this should be a -1 also. Both of them are -1.
Is it vice versa? Is it vice versa? You put f -1, the inverse is f of x?
Yep. If in two functions are always inverses of each other. It's a -1.
A negative what?
1.
Okay.
That's our notation for inverse, is an exponent of -1. Both are -1.
Okay.
Yeah. I know it's hard to see, guys. Here, let me zoom it in for a second. Does that help?
Oh, yeah.
Yes.
I have to zoom it out in a second, but for writing this part, I'll zoom it in.
Thank you.
You're welcome.
Line.
So anytime you have an inverse, you use a -1 exponent to indicate that it's the inverse function. Okay? So it's a new type of notation. Yeah, I know the exponents come out small. You okay? You got it?
We're talking about how bad
Okay. So, how do I find inverse functions? What you're going to be doing, sorry guys, what you're going to be doing in these problems is your instructions are going to be find the inverse of this function. So that's all we're going to need to know how to do. So how do we do that? It's pretty straightforward. As soon as we start doing examples, it's the same process over and over. What you're going to do is you're going to exchange x and y in the equation. So literally, where in the original equation where you see x, you're going to write y, and where y originally was, you're going to write x. So we're just going to flip-flop them. Now, however, we always want our equations to be equal to y. We want y by itself. So you're going to solve that new equation for y. So after you flip them, you're going to work backwards to get y by itself. That's how you find the inverse. So after you get y by itself, instead of leaving it as y, it's now an inverse. So you want to make sure that you note it as y inverse equals, so that we know that you found an inverse function. So that's what makes it an inverse. Okay, you guys ready for the first example? Still writing? Who's still writing? You got it? You got it? Okay. Hold on.
I try to actually read next time. I got it.
You good? You sure?
Why did you pick this classroom for?
Go ahead.
This is why our videos are so long.
They're not long.
Okay, example 1. You guys are going to like this, I promise. Okay, y equals -3x plus 2. This is your function. And your instructions are to find the inverse. So the first step, let me put the steps back up for this one. First step is we want to exchange x and y. So we're going to take x and y and we're going to flip their positions. So it's going to become x equals -3y plus 2. Now remember, we always want our equations to be y equal, so we want y by itself. So we have to take this and solve for y. So my first step in solving for y, subtract 2 from both sides. So that's going to give me x minus 2 equals negative 3y. And then last step of solving for y is I divide both sides by negative 3. Now remember, that subtraction is like glue. This x minus 2 is one number. It's stuck together. So when we're dividing by negative 3, we have to divide the whole thing by negative 3. Okay? So that's going to give me, now that I have y by itself, step 3, I can write it as an inverse. So y inverse equals whatever we got down here. X minus 2 all over negative 3. And that's it. We just found an inverse. You can have a negative in the denominator. Yeah, you could also stick it on the outside though, if you wanted to. And that's it. Not too bad? It's something you already know how to do. You just needed the first step of flipping them. So let's look at example 2. Okay, new function, y equals negative 2/3 x plus 7. So example 2, y equals negative 2/3 x plus 7. To find the inverse, what's my first step, guys? Flip x and y. So take y and x and switch them. So that's going to give me x equals negative 2/3 y plus 7. Okay, so all I did was flip x and y. What is my first step in solving this thing? Subtract 7. So I'm going to have x minus 7 equals negative 2/3 y. I need to get rid of that negative 2/3. How would I get rid of a fraction? Multiply by the reciprocal. Does the reciprocal change the sign? No. So the reciprocal is going to be negative 3/2. So multiply both sides by negative 3/2. So the 3's cancel and the 2's cancel. So as my inverse, I'm going to get y inverse equals negative 3/2 times x minus 7. Well, this is not the most simplified answer that we have. So what we want to do is we actually want to distribute that negative 2/3 into the parentheses. Negative 3/2, I'm sorry. So that's going to give me negative 3x over 2. And negative 3/2 times negative 7 gives me positive 21/2. Now notice I have common denominators, so what can I do? I can put them all over the same denominator. So y inverse is equal to negative 3x plus 21 all over 2. That's your most complete answer. You could go straight from here to here. Okay, I don't have to see this step. Okay, so you can go straight from here to here. I just wanted to write it down at least once to show you why it is all over 2.
Couldn't you just multiply the 2 and then divide the...
Multiply the 3 and divide the 2. Yeah. Okay? Not too bad, guys? That's pretty much as difficult as it gets. Let's look at something with squares in it. So example 3. Your function is f of x equals x squared. Okay, f of x, you guys remember that I told you f of x and y are basically the same thing? It's just a different way of writing y. F of x is a different way of writing y. So what we're going to do is the same type of idea. We're going to take f of x and just flip-flop them. So this is going to be x equals. I suggest that you put f of x in parentheses just so that you keep it all together, and then square it. So this is acting in the same way as y. Just because our original function is given as f of x, that's how we want to write our inverse. So I'm trying to get that f of x or that y, because they're the same thing, by itself. So what would be the opposite of squared? Square root. So square root both sides. That's going to get me my f of x by itself. So the f inverse of x, so you need to write it as an inverse, is equal to the square root of x. That's your inverse. Not bad. One more like this, and then we have one other thing that we have to talk about. Example 4. F of x equals negative 10x to the 6th, where x is less than or equal to 0. Write this part down. This is a specification that we have to make in this type of problem. It will be given to you. You don't have to know why or how it's there. I'm going to explain to you why it's there. But you will not be expected to include this. It will be given to you as part of the problem. Okay. After we find the inverse, I'll show you why we have to make that specification. Okay. So to find the inverse, all I want to do is switch f of x and x. So we're just going to flip them. So that's going to give me x equals negative 10 times f of x to the 6th power. Now before I can start solving for f of x, what do I need to do first? I need to get it by itself. Do I have to divide negative 10 or root it first? Divide. So divide both sides by negative 10. So that's going to give me x over negative 10 equals f of x to the 6th power. So to get rid of the exponent 6, I need to take the 6th root of both sides, which will get f of x by itself. So it's going to become f inverse of x equals the 6th root of x over negative 10. The reason why we have to only plug in x's that are less than or equal to 0 is because in our inverse we have a negative underneath the radical. So in order to make that radical positive, we have to have a negative in that fraction. That's why it's specified. You don't really have to worry about it. Okay? It's just written in the problem. Not too bad? That's it. We do have to look at graphs. We're going to talk about the graphs, and then we're going to do one graph together, and then we're done. So, when we are graphing these inverse functions, you remember how when we're doing it algebraically, we flip the x and the y? In the graph, on the graph, it flips the x and y coordinates. Okay, so because the inverse changes the x and y values, it also changes the x and y coordinates of the graph. So, for example, if my original function has a point 2, 3, the corresponding point on my inverse function would be 3, 2. So we just flip them, the x and the y. Which is going to make graphing actually really nice for us. One other note we have to make about the graphs. The graph of the function and the inverse are actually symmetrical. And they're symmetrical about the line y equals x. So the line y equals x is a diagonal line going through 0, 0, and it has a slope of 1. So when you're just drawing a line on a graph through 0, 0, it's most likely the y equals x line. But they are symmetrical, meaning if I fold along that line, my two lines would look exactly the same. So you guys remember, like in kindergarten, when you're learning about symmetrical stuff and you paint on one side and then fold it over and the two sides are the same? That's what it means. The two graphs are symmetrical if you were to fold the paper in half. Yeah, you have to write it so that I know that it's an inverse.
I have some colorful notes.
Okay, guys. We are going to do one graph, so you can go ahead and set up your axis right now. Okay. So we're doing one graph, and then we will be done. For this problem, we are going to graph the function. We're going to use that graph to graph the inverse. And then we have to determine whether the inverse is a function. Because, and you're going to use the vertical line test for that. The reason why we have to determine if the inverse is a function is just because the original graph is a function does not necessarily mean your inverse will be a function. Okay? So we have to use the vertical line test in order to test that. So our original function is going to be f of x equals 2x minus 1. So draw your x and y axis, and we will get started in just a second. Okay, guys, the good thing about this graph is that we're not going to do any algebraic work to find the inverse, okay? But we do need to know how to graph a line. What is the y-intercept of this line? -1. So put a point at -1. What is my slope? So my y-intercept was -1. My slope is 2 over 1. So we're going to go up 2 over 1. We're going to use these points to find the inverse. So I suggest that I want you to graph at least 4 points. Okay, so from this point, I'm going to go up 2 over 1. And then just for kicks, I'm going to go from the y-intercept down 2 and to the left 1. Okay. So I want you to find 4 points on that line and then go ahead and graph it. And let's label that f of x. Okay? So I want you to find 4 points on the line. What we're going to do with these points is we're going to use them to find 4 points on the inverse. So for the f of x function, let's make a t-chart of x's and y's.
I don't get this.
We haven't done anything yet.
0, -1.
It's higher than this.
It's like the 0, -1.
Kind of, yeah. Yeah, so what we want to do on our t-chart is for each x, we're going to put the corresponding y. So, for example, my very first point, the x is -1. The y is -1, 2, 3. For my middle point, the x is 0. What's the y? -1. What are the coordinates of the third point? 1, 1. And the last point, my x is 1, 2. And the y is 1, 2, 3. So all I did was make a t-chart for the 4 points on my graph. Everybody should be okay so far because this goes all the way back to Algebra 1, right? Okay. So here's what we're going to do next. We're going to use these points to find points of the inverse. So make another t-chart, x and y's, for the inverse. And here's what we're going to do. My first point of the f of x function is -1, -3. So the point on my inverse is going to be -3, -1. I just flip them. Because when I'm finding inverses, I just flip x and y, right? So that's all we're doing on the graph as well. So what would the next point be? Good, -1, 0. The next one, 1, 1. And the last one, 3, 2. Graph all 4 of those points, please. So -3, 1, 2, 3, -1. -1, 0. 1, 1, so those share a point. And 3, 1, 2, 3, 2. So draw a line through those 4 points. And let's label that f inverse of x. So what I want you guys to notice is that these two lines actually are symmetrical. The line that they're supposed to be symmetrical around is the one that goes corner to corner through 0, 0. So it's a kind of an invisible dotted line that goes corner to corner, y equals x. If I were to fold my paper or my graph along that dotted line, do you guys see how they would become symmetrical? They would be touching each other. So that means we graphed it correctly. So the last question, is the inverse a function? So the inverse is just the purple line. So let's do the vertical line test on it right now. So I'm going to take my pen make a vertical line on my graph, and we're only looking at the purple line, and we're going to pass it through. Does it ever touch my vertical line more than once?
No.
Not on the purple line. We're ignoring the blue one. So as I pass my vertical line through the purple line, it never touches. So is it a function? Yes, it is. So f inverse of x is a function. And that's it. I want to show you a quick example of when it won't come out to a function. You don't have to write this down, but I do need all eyes up here. Okay, so this one that I'm skipping because I think graphing is pretty straightforward. Our first function that they give us is just a set of points. So all we have to do is graph those 2 points. So my first one is -3, 1, 2, 3, positive 5, 1, 2, 3, 4, 5. And my second point is -2, 5, so that's going to be right here. And this is a horizontal line. Okay, that's h of x. So if these are my 2 points, h inverse of x, the 2 points would be 5, -3, and 5, -2. So all I'm going to do is graph those 2 points. All I did was flip-flop the x and the y's. So that's going to give me 1, 2, 3, 4, 5, 1, 2, 3, and 5, -2. So the inverse is going to be a vertical line. This is h inverse of x. Okay, these two are symmetrical. If I was to take that y equals x line all the way through and fold my paper, they would still come out to be symmetrical. But the big question, is the inverse a function? If I pass my pen or my vertical line through the graph, it's not touching anything at all, but as soon as I hit that point, is it touching the line more than once? Yeah, it's touching at every single point, right? So h inverse is not a function.
If you go sideways, it's not. Can't you go sideways and go up?
You mean like this?
Yeah.
Well, it's called the vertical line test, which means your line has to be vertical. So no, you can't. Okay? Vertical lines are not functions, always. So that's an example when the inverse is not a function. Okay? So functions, you flip x and y, solve for y, and you're good to go. On the graph, you just flip the coordinates. Okay?
There should be a horizontal